Hello, good morning my warriors. Welcome to the last and the fifth session of magnetic sources and effects. And today we are going to see some amazing questions with me, Shreyas, your physics master teacher at Vedantu. Good morning my warriors. Your captain is here. Hi Priyanka, hi Jai, hello Alia, hello unknown Krish, welcome Samuel, hello everyone. Good morning, good morning, good morning. I'm Shreyas and I'm your physics master teacher. And I not only teach on YouTube but also on the regular paid platform of Vedantu. I am so happy to be here to spread the joy of knowledge to all the people out there in our country who want to learn, all the tips, all the tricks, and all the intricate, concepts in depth out here for free on YouTube, and that too in English medium. So welcome aboard. And if you want to know more about me, do not forget that you can always contact me on my Instagram handle, that's Shreyas_Vedantu. Hello Ritesh, hello Prem, hello everyone. I'm not sure why Ankit got blocked. Okay, let me just message our admin. Admin, please don't block Ankit. Ankit is our regular, student. And yeah, probably. Just one sec. Okay, cool. Yeah, hello Arthi, hi Samuel, welcome aboard. So let me show you the schedule today. Hi Shagun, welcome. So yesterday we had a logical reasoning and English mock test for BITSAT. If you have not attended it, even if you are a 12th standard student who is going to give the BITSAT examination next year, trust me, just watch this session. Just watch this. You will enjoy it. Not just for logical reasoning, but even in English. Trust me, the questions are really interesting. Watch that. So today will be our last session for magnetism. Now, since there is examination coming up for the 2021 students, so guys, I need your support. In fact, 2021 students, your seniors need your support. So we need to help them in these very tensed, stressed, difficult times. So we are conducting a lot of sessions for them. But don't worry, I'm going to have coffee with you guys on 15th, and that's Thursday in the evening. So I'll be there for you for a casual interaction. Plus, there is some special news which is going to pop out during the session. All right. So we have to conduct these sessions. So till their examinations are over, please bear with us so that we can help them out. Don't worry. Meanwhile, you can revise through all the playlists, catch up, and make sure your backlogs are clear. As soon as their exams are over, trust me, we are coming out over here with full force. And you can also attend these 2021 sessions. There is no harm in attending. Most of the questions, half the syllabus at least you would know. 11th standard and 12th, the initial chapters, you would definitely know about it. Okay? Yeah. So Jayvant, it's really difficult. Even if there was one session possible for 2023, trust me, I would have done it. But even these sessions are, less, I would feel sometimes, because we need to make sure that, all our passing out students, your seniors, do really well. Trust me, we are going to do the same thing for you guys when you reach in 2023. So after 2 years, we'll be doing the same thing, and I'll be telling to your juniors, 2024 and 2025 juniors. So don't worry, we are always there with you. Just bear with us for some time. So I hope you guys are ready to support your seniors. Just let me know by putting up a V symbol, because these Vedans need victory. They need your support. Just put up a V out there. And yes, do not forget to smash the like button right now to show your support for our channel. And if you are new to our channel, do not forget to hit the subscribe button. Now remember guys, those of you who want a regular batch, and if you have still not joined a coaching, or if you are not happy with your coaching and you want to consider Vedantu, I will give you one big reason to join Vedantu. See, in fact, I'll give you two reasons. Number one is VIP. VIP is nothing but Vedantu Improvement Promise. And in this promise, what we give you is a guarantee that you will improve. We conduct tests when you just join Vedantu, and we will conduct tests when you are about to end your course. Now, if you do not improve, all the money is returned back. All the fees is returned back. This is unheard of. It has never happened in the coaching industry. This is a guarantee which Vedantu gives you, because we are confident of our teachers, we are confident of our tests, we are confident of our assignments, we are confident of our doubt solving abilities, We are confident about everything that we do out here in Vedantu. Not just that, guys. If even before this, last year, if you see the results of Vedans, the students who studied in Vedantu, be it 10th standard, be it 12th standard, be it JEE, anything, it's 5 to 6 times higher than the national average. So people who are not studying with us, they are performing substantially lower, whereas the Vedans are performing really well. So this should give you that confidence, that moral boost that yes, joining Vedantu is the right decision. And there are lots of packages, in fact 3 packages out there, depending on whether you want doubt solving or personal mentor. And these packages come with everything, your test series, notes, analysis, recordings and all of that. And they are as low as 3,000 rupees per month, which is very, very affordable. In fact, you can use my coupon code SHHPRO and you will get 10% off. So there is a link in the description box. Use that link and join the pro subscription at least for a month. Try it out. If you do not like it, it's okay. You can leave it. No problem. Just try it out for 1 month at least. Okay. Now there are some amazing questions out here. Thank you so much, Shekhar. Thank you everyone who have put that V symbol. Your seniors need that. Yes, Nikhil Reddy, I do remember. Every day you ask the same question, but I do remember you. Okay, Ankit is somewhere in the desert or in the ocean. I don't know where he is. Yeah. Okay, cool. Let's get going. And look at this question. This looks very interesting. Looks like a modern art. Read the question by yourself. Meanwhile, and here we go. A uniform magnetic field is existing in the vertical direction in a region. This is not uniform. This is non-uniform. Why has it become non-uniform? You will understand. There is a long current carrying wire having current I, okay, and it is placed horizontally. So earlier the magnetic field was uniform in the vertical direction. You have a wire carrying current I in the horizontal direction. It's shown, that dot I, it's coming towards you. Okay. Now the resulting field due to the original uniform field plus the field which is created by the wire together gives these field lines. Earlier there was uniform field, okay, upwards. Now you place a wire. Because of that, both of them together will produce this non-uniform field. Now the question is, in which direction do you think is the wire which is carrying that current will experience magnetic force? Very interesting question. Very interesting question. Let's see. Munaba is asking, do we need to use integration? I don't know. You need to think. What do we need to do? Earlier there was uniform field. Now there is a wire which is placed. Because of that there is a resultant field. So first thing what we should do is think about it. When there was no wire, how will the field look like? Let's draw that first. Let's think about it first. Okay, so without the wire. So this is without the wire. The field was uniform. So there was uniform field. Okay, and how was the uniform field? Obviously like this. Just draw straight lines, nothing great about it. This is how the magnetic field look like. Now, how is the magnetic field due to a wire? Due to a wire which carries current in the horizontal direction. So horizontal is like this, placed in and out of the plane of the board. So if you have a wire which carries current like this, it will create a circular magnetic field around it. We have seen that there is a circular magnetic field. So let me draw concentric circles like this. Now the addition of this and this is going to give you this. This plus this is going to give you this. Correct, guys? I hope this is clear. Glad to know that, Nikhil, you are loving the crash course. Yes, Aman, Jai Hind, welcome aboard. Come on, let's see how do we do this. Mathurun, I love Wasim sir, man. I love all the teachers, not just Wasim sir. Shimon sir, all the teachers in Vedantu, in fact not just Vedantu, all the teachers who are on YouTube, who are not on YouTube, who are teaching students are, lovable, are doing a great job. It takes a big, heart. It takes a big, bold decision in their life to actually come up and teach students. And trust me, not many people, who are knowledgeable also come to the teaching profession. They prefer going to some industry, but hats off to all the teachers who are actually teaching everyone, and especially on YouTube and free platforms like this. Really hats off to every teacher out there, not just Vedantu teachers. Remember that. Okay, so yes, we do love all the teachers. Yep, correct. So let's see what do we do next. Now look at this diagram carefully. Where is the field strong? Is it strong towards the left side or is it strong towards the right side? Come on, answer this question. Is the field strong towards the left side or is it strong towards the right side? And remember, the field is stronger where the lines are closely packed, and Ankit says it is towards the left. Correct, it's towards the left. So it's a strong field over here and there is a weak field over here. That means to the left of the wire, the field lines, these field lines and these field lines should add up each other. This field and this field should add up each other. That means on the left side the field lines are here, so these arrow marks and these arrow marks will add. On the right side, since it is weak, that means they are cancelling each other, okay, partially at least. So that's how the field lines are. Is this point clear? So on the left side of the wire, the external field and the field by the wire adds, and on the right side, the external field and the field because of the wire partially cancels, so it becomes weak. Cool. Now the moment I get this, use your right hand and curl your fingers in the direction of the field. Curl your fingers of your right hand in the direction of the field. You will see the thumb is going inside. Did you just see the thumb going inside? If the thumb is going inside, what it means is that the current flowing inside that wire is like this, inside the plane of the board. So the current is going inside. Interesting. This is my external field. This is obviously my external field. Okay. So what is the force acting on a wire? The force acting on a wire, remember, is IL cross B. IL cross B. That's the force acting on any current carrying wire. Where is length? This length is inside. That means I put a cross. Where is magnetic field? That magnetic field is, where is this magnetic field? This is upwards, right? Its magnetic field is upwards. So L cross B, just do this cross product. A length vector is inside, magnetic field is upwards. L cross B, guys, just do L cross B. Come on, do L cross B. IL cross B, use that. Length is inside, so take your four fingers, put it in that direction inside, then cross B, so shift it upwards. It's like asking somebody to come over here. I'm acting as if I'm a student watching the screen. So length is inside, B is here. Ask somebody to come towards you. You will see the thumb will go towards the right. So this force, where is this force going to be? This force is going to be towards the right side. So hence the answer to this question is right. Hello Lakshmi, welcome aboard. PL, I had to change the timing because there are a lot of classes for 2021 coming up, and these are in the evenings, and plus I have my regular classes also on the pro. So to avoid clashes, and plus Wasim sir, Shimon sir also have to take classes. So a lot of things are happening this week. It's a very busy schedule. That's why we had to keep it in the morning. Hello Anand. Did you guys love the question? The answer is right. Yes. The answer is towards the right. So what were the ideas? The ideas were external field plus the field due to the wire is this field. So I tried to first figure out in what direction is the field produced by the wire. Just looking at the strength. So there is more field here, less field here. The moment I got the field, I found out the direction of the current by using right hand thumb rule. Once I know the current and once I know the outside field, I use the formula IL cross B. Length was inside, magnetic field was up, so I found out the direction of the force. Is it interesting? Did you guys loved it? Very good. If you guys have loved it, it's a beautiful question, guys, which is advanced level question, and the answer is towards the right. Let's get going to the next question, which is going to come up on your screen. Now there is a wire, okay, and I think each side has not been mentioned, but it's okay. So there is a wire and it's carrying current like this. There is a square loop of side length and it is carrying current I in the clockwise direction. It's carrying current I in the clockwise direction, and the question is find the force on this part, this part, this part and this part. all the parts you have to figure out the force. So let's try to do this question, guys. It's very interesting. First, let me mark the points. Let's say this is A, this is B, this is C, and this is D. So the current in this wire is going like this. Okay, the current in this wire is going like this. So another wire which is carrying current I0. So this wire is carrying current I0, and this wire is carrying current I. Okay, that's the diagram. Now, first thing that we'll do is, because the question is find the force, obviously we need to use the formula IL cross B. Now, I know the lengths and I know the current, but I don't know the field on this wire, on this loop. So, to figure that out, first think, why will there be field over here? The reason for that field is because of this long wire. This long wire will produce circular magnetic field around it. So use your right hand thumb, put it in the direction of I0. You will see the fingers will curl like this. So if this was the wire carrying current upwards, the fingers will curl like this. So on the left side, the field lines are coming towards you. They go around and they hit inside the plane on the right side. So you can see the field lines are curling like this. So I will show magnetic field lines something like this over here inside the plane. And as you go far away, understand the field lines are going to become weaker. The reason for that? Because the distance is increasing. So over here, the field is very, very weak. You can see I have shown a strong field here. So that's why there are more field lines. As you go away from the wire, the field is going to become weaker. Is this clear? Is everybody clear about this? Okay. Now, what happens next? Look at this. Thank you everyone who are giving those hearts, and all of them. Welcome aboard. If you are new to the channel, do not forget to smash the like button and hit the subscribe button so that you do not miss any videos. So, this wire carrying current has produced a circular magnetic field. The circular magnetic field will go like this, and on the right side it will go inside. And we all know the formula for magnetic field at any distance from this wire. What's the formula for the magnetic field? It is mu naught I, here it is I naught, divided by 2 pi into the distance. That's the formula, and that's why you can see as the distance increases, the field reduces. Great. Now, I hope Maheshwar, now it's clear. It's very simple. It's just a normal wire. If you have attended the previous sessions, I'm pretty sure you will get it. Now, think about this. For the segment AB, okay, so the force on the segment AB will be equal to L is this length, into B, IL cross B. So I, length of AB, cross the magnetic field over there. Now think about it. Length vector should always be in the direction of current. So length vector is upwards. Length cross B. Where is B? Magnetic field is inside. So do length cross B. Do length cross B. Where is the thumb coming? The thumb is coming towards your left side. So this force is going to act towards the left. I is I. Length is L. B is this value, which is mu naught I by mu naught I naught by 2 pi into distance. What would be the distance of this magnetic field from the wire? At what distance is it? Think about it. Thank you, Tushar Bacha. Think about it. So this field from this wire, how far is it? It is at a distance L. So this distance will be L. I hope this is clear. Yep, correct, Anand. Yep. So IL cross B. So the force, where is the force acting? It's acting towards the left side. Okay. So therefore, that force AB, which is acting towards the left, will be equal to length goes mu naught I naught I divided by 2 pi. Check this out if everybody is clear about this. Everybody fine? Hello Hanum, welcome aboard. So this is the first part, but there are many more parts to this because the question says find the force acting on each segment. Now if I know AB, I can also find CD, guys. It's not that difficult. I mean, look at this. The force acting on CD will be I length of CD cross magnetic field over there. Now I is I, length of CD is L, B over there, look at that distance, this is L, this is L, so the total distance is 2L, so it will be IL B, which is mu naught I naught by 2 pi into 2L. Now L cancels, so again you will be left with mu naught I naught I divided by 4 pi. This is the force acting on CD. This is the force acting on this wire CD. It is at a distance of 2L, so the magnetic field is less, so these two forces are not equal, you can see that. Now the thing is, which direction will be the force? Well, that's not difficult to answer. I mean, come on, if this wire was carrying current this way and the force was towards your left, so obviously the force on this wire will be towards the right. It's obvious, but still if you want to do it, no worries, length vector is down. So hold your right hand like this, length vector is down, okay, and magnetic field is inside the plane of the board. So length cross B, you can see the thumb goes towards the right side. Hold your hands like this, hold your hand like this, length going down, cross B, B is inside. You will see the thumb going towards the right side. So this force is going to be towards the right. Everybody clear? So I will just block this answer and I will just block this answer. We have got two answers till now. I don't need any of this, but still I'll just keep it. Now here is the thing, guys. Yep, Giri, correct, the force will be on the right. So Hanum, the question is basically you have to find the force acting on each segment of a loop which carries current due to a magnetic field produced by a long wire. So this long wire is producing magnetic field. You can just go back in time. You can just slide the slider on YouTube. I believe you joined a little bit late. You will understand. I explained the question at the start as well. Okay, just do that. Now, the problem is not for AB and CD. The problem is for BC and DA. Why is there a problem for BC and DA? Can anybody tell me what is the thing which is different? What is different for the calculation of part AB and BC? There is something which is different. Think about it. What is different? What is different? Remember, look at these magnetic field lines. Do you see these magnetic field lines? There is something which is different. What is different, guys? AB is left. Not just that, Anand, there is something different. Magnetic field is not uniform on that entire wire. So yes, the magnetic field is not uniform. So that creates a big problem because each length will experience different amount of force. So if one takes this side BC, okay, if one takes this side B to C, understand when I show this magnetic field and which is at a distance of, let's say, X from the wire, okay, X from the wire which is carrying current I naught, this B magnetic field is mu naught I naught by 2 pi X. As X changes, B changes. As B changes, the force will also change. So this will experience a small force, let's say DF, for this small length, which I call dx. So this dx length which is there will experience a small force df, and each part will experience different amounts of forces. When you're close, the field is stronger. When you're far, the field is weak. So you will see it will be a variable force. Every point is experiencing different amount of forces. This will experience least force, and as you go towards the wire, the force will keep increasing. So that's why you need to integrate. Yes, you need to bring out the snake and you need to integrate. Hello Achi, welcome aboard. Yes Yalini, your comments are visible. Yes, depends on R, correct Giri. Yep. So what you need to do, consider a small element, think what is the value of df. What is this df force? This force, by the way, why is force acting this way? Use IL cross B. Where is the length? Right side. Where is the field? Inside. Length cross B is up. So that's why the force is acting upwards. So this force will be, okay, I. The current flowing through this wire, how much is the current flowing? It's I, right? Okay, so it will be I. Length of this small element is dx into B, which is mu naught I naught by 2 pi x. This is the force acting on the small part. So think, what will be the total force acting on this wire? That total force will be addition of all the df's, df plus df plus df plus df, all the elements. So it will be nothing but integral of all of this. Look at what are the terms which are constant, like mu naught, I naught, I divided by 2 pi. All these are constants. Only thing left inside the integral is dx by x. Nothing else is remaining. Nothing else is remaining. Now, once you understand this concept till here, since the forces are different on all the elements, that's why we need to integrate it. The only thing left is now the limits of integration. So guys, observe the diagram carefully and think what would be the limits of the integration. What would be the limits? Yes, Vicky, I have already done the charges lesson already. Definitely I have done it. You can check it out in the playlist. See, where is x measured from? From the wire. The first element is B. The last element is C. So the value of x will start from this length, from wire to B. How much is this length? I know the wire till this length is L. So it will start from L and the last point is at a distance of 2L. So that's why it will go till 2L. Look at that. Yes, from L to 2L. Who was that? 4004. Correcto. Thank you, Lakshmi. Thank you, everyone out there. Now, once you understand why the limits are not from 0 to L, a lot of people think, sir, the limits will be 0 to L. Now, see, what is this x? X is from the wire, this wire. So it starts from B and goes till C. So just do this. Mu naught, I divided by 2 pi. This is dx by x. Integral of 1 by x is ln x, log to the base e. So it is ln x. And first put 2L and then put L. We'll do that. So this is 2L to L. So this will be mu naught, I divided by 2 pi. And you will have first put ln to L and then put ln L. Now everybody knows this. Log of A minus log of B is log of A by B. So I might as well do this. That would be better. And the best part is, you know, this L and L cancels out. So that would be the final answer. So this is the force acting on this. Yep. So mu naught I ln 2 divided by 2 pi. That's the final answer. That's it, done. The direction is upwards for BC. So for BC it is up. For AD obviously it will be down. For this guy it will be here. For this guy it will be here. Think and tell me, will this force on BC and this force on AD, will it cancel or not? Yep, it will be opposite. Just answer this question. Archie, let's see for EMCT, I'm not sure, but we'll let you know. But put up all your comments later on in the comment section, probably I'll look at it. So will these forces cancel or not? Yes, they will cancel. The force on BC and the force on AD, they will be equal. They will cancel out each other. So there is no force in the y direction. Yes, they will cancel, because obviously whatever integration you do from B to C, you will do the same integration for A to D. Magnitude wise it will be same, limits wise also it will be same. So magnitude wise they will be equal and direction wise they will be opposite, so they will cancel. Will force on AB and CD cancel out each other? You can see that. Will force on AB and CD cancel out each other? Yes or no? Kishore, oh my god, I'm really sorry to hear this, bacha, but please stay strong. Don't worry, COVID is curable now and a lot of people get tested positive. I'm pretty sure she will recover very fast. All my wishes and all the V enthusiasts wishes are with you. I hope she recovers really fast. Please stay focused, bacha, because this is your lifetime, you know, decision making thing. So you need to please focus. Don't worry, she's going to recover. Yes. Okay. A lot of you are saying they will cancel, but no, they will not get cancelled. You can see the magnitudes are different. They will not get cancelled. Many of you also said no. Very good. Reason is this force is larger because this field is stronger. This field is less because the distance is more. So actually the net force, if you talk about the net force, where will the net force be? It will be towards the left side. Yeah, it will be towards the left side because this force is more, this force is less. These two cancel, so the net force will be towards the left side. That's how it is. Understood? What a brilliant question. And if you love this question, do not forget to hit the like button, guys, to show your love and support to this channel. Well, I have put up all the answers out here just in case you need it. Now let's go to the next question coming up on your screen. This has SHM. This has SHM. Come on. Yo, my warriors. Now look at this question. There is a large coil of radius capital R, carries current capital I, and it is coaxial with a very small coil, the red one, of radius small r, carrying current small I in the same sense. Same sense means if the outside coil is carrying current clockwise, the smaller coil is also carrying current clockwise. So that's the meaning of same sense. The small coil is free to rotate about the diametrical axis. It's free to rotate about the diametrical axis. Now question is basically what's the what's the time period for small angular disturbances? Figure this out. How are we going to do this? Now those of you are unable to understand what exactly is happening. So imagine this is the small coil. It's free to rotate about the diametrical axis. That means it can rotate like this. So it can rotate like this. Understand? So this is the diameter, obviously. It can rotate like this, and if you disturb it, it will oscillate. So it oscillates like this. So the question is, what's the time period of oscillation? Now, the whole idea is, whenever you see oscillation, the first thing that should click in your mind is, I need to find the force or the torque. But since this is angular, will you be interested in force or torque? Come on, angle, rotation, obviously torque. So somehow the logic should be showing torque is something, some constant, okay, multiplied by, the angular displacement. The angular displacement. If you rotate it by theta, so torque is k into theta. Just like F is kx, here torque is some constant into theta instead of x. Once you get that constant, this is very important, the time period is very simple, guys. It's going to be 2 pi under root moment of inertia divided by whatever constant you find. Remember, in linear SHM, it used to be 2 pi under root mass by k. Instead of mass, obviously angular mass, which is moment of inertia, is the mass in rotation. And instead of k, which is a spring constant, you will have that constant which comes in this force or the torque equation. I hope this is clear. Now, the whole idea is to somehow figure out the torque. So guys, now think reverse. How do you find the torque on a coil? Is there a formula for that? Yes. Torque is magnetic moment into field. I hope you remember that. So the torque is nothing but magnetic moment, magnetic dipole moment multiplied by the external field acting on it. I hope you remember M cross B. That's the formula for the torque, external field. M cross B. Very good. Now, can I find the magnetic moment of the small coil? Yes, I know the formula. The magnetic moment formula is NIA. I have been telling you. Magnetic moment formula, NIA, National Investigating Agency, like CIA. So that's the easy way to remember it. Similarly, can I find the external field? Oh, I think so. External field. Who is giving that external field? The outer coil. The outer coil. Remember, the coil carrying current produces magnetic field. And we know the formula for that. It is mu naught I by, actually this is capital I. Okay, mu naught I by 2 R. R is R, capital R. So this is the outer coil. The outer coil which is producing the magnetic field. Everybody clear till this point? If you are clear, please put up OK or thumbs up or clear O in the chat box. Glad to know that, Yasir. Thank you, Lakshmi. Yeah. Now, so the outer coil is producing magnetic field. That magnetic field is causing a torque on the smaller coil. So this is how you solve a problem. A lot of people ask, sir, how do you understand which formula to use? Think reverse. Sometimes that might help. Maybe forward thinking might not help, reverse thinking might help. Okay, great. Now let's do this. Let's use this formula step by step. So the torque, okay, first magnetic moment we know Ni, okay, cool. So do I know the value of N out here? I think so. Number of turns is 1. Number of turns is 1. Current is I. Area is pi small r square. So that's the magnetic moment of the smaller coil. So let's do this. The torque acting on it, which is mb sine theta, because it is m cross b. Cross product is always ab sine theta. The value of m, I just figured it out. It's I into pi r square into the field, which is mu naught I naught or capital I, mu naught capital I, divided by 2r into sine theta. Just check this out. This is the value of the torque. See if everybody is clear till this point. Now, the logic is somehow showing torque is some constant into angular displacement. But here we have sine theta. So think carefully. It's clearly mentioned the disturbances are small. When disturbances are small, sine theta is roughly theta. That's the small angle approximation which you should use. So this will become mu naught pi capital I small I r square divided by 2r. Instead of sine theta, just put theta. That will give you the torque. So hence, isn't this the constant which we were looking for? Isn't this the constant which we are looking for? So the time period, think about it. The time period will be 2 pi under root moment of inertia by this value, which is mu naught pi I r square divided by 2r. That's what I got. Yep. Now here is the last catch. The only catch left is moment of inertia. What is the moment of inertia of this loop, the small loop carrying current? What is that? It's a ring, right? And I think I know what to do. For a ring, and I want to find it for the diametrical axis, draw two diameters, because you need to use perpendicular axis theorem. Why do you need to use perpendicular axis theorem? Because for a ring, you only know the moment of inertia for a vertical or the axis which passes through the center like this. So you do not know for this axis or for this axis. But obviously this and this is the same by symmetry. So I think you need to know what is perpendicular axis theorem. So moment of inertia about this axis plus moment of inertia about this axis is the moment of inertia about this axis, which is mr square. So I will be equal to mr square by 2. So this is what you're going to put over here. So mr square by 2. That's what you're going to put. Yes. Jayashree, this is magnetic effects and sources. So probably the chapter name is mentioned below in the description box as well as the title. Now a lot of things are going to get cancelled, guys. r square got cancelled. This 2 and this 2 also got cancelled, and that should be the answer. Okay. So if you want, you can also cancel this pi a little bit, and you can probably put it inside. So you will get 2 root m. This pi went inside because there is, when it goes inside, it will become pi square, or pi over here will get cancelled. You can think about it. So 2 root m, and that pi came inside, and that r is there, and then you have mu naught over here. Pi got cancelled. You just saw that I, and that's it. This is what you're going to get. Yeah. What a beautiful question. Yep. Hanum, I'll do that as soon as 2021 exam is over. Trust me, I'll conduct a strategy session. Just hold on for now. Just follow these lectures. Yes, Siddharth, this is a JEE Advanced session. I hope you saw the lecture title. It just mentioned JEE Advanced questions. Yeah. Okay. So that's the answer, guys. Beautiful question. I hope everybody is clear about this. Let's get going to the next one coming up on your screen. Now this is another beautiful question. Just read the question. Hanum, I just told you, bacha. Okay. Now, if you observe this question, what is happening? There is a wire. It's carrying current. You can see there is current in that wire. There is a charged particle. It comes from the left side and it gets deflected in a brief moment. So I'll spare you. Forget reading this question. I'll just tell you what is happening. There is a wire which carries current. You throw a charge. When the charge goes, it gets deflected by a very small angle. The question is find theta. Question is find theta. First, think why the hell would this charge get deflected? What is the reason why the charge should get deflected? Because of a current carrying wire. Is there something, some phenomena is happening? Just think about it. I feel something is happening. What is happening? What does a current carrying wire do? It creates magnetic field. So, yes, there is a magnetic field because of this wire which is carrying current. So, use your right hand thumb, see where the current is. The current is here. See how your fingers are curling. It's curling like this. So, there is magnetic field going inside the plane from the top and comes from below towards you. So, what will happen? Let's see. There is magnetic field inside. Okay, magnetic field inside the plane of the board. Okay, cool. And let me just call this as B. What's the value of B? Well, that's mu naught current in that wire, which is I, divided by 2 pi into the distance from the wire. We know that. Distance from the wire. Great. Now what happens because of this magnetic field? Remember, force acting on a charge. Force on a charge. What is the value? It's QV cross B. Yes, that's the force acting on a charge which is in motion. So think about it. Velocity is there. Velocity is there. Magnetic field is inside. Do velocity cross field. Velocity cross B. Where is it? It's coming this way. So the force is acting like this. This is how the force is. Interesting. So now it makes sense why the charge gets deflected. Is everybody clear about this? Beautiful. So that's the reason why the charge got deflected, but that's not the question. The question is find this theta. Now you need to make some assumptions. They have told us that the charge goes from this end to that end really quick. Neglect the end effects. Think as if the field produced by this wire is like the field produced by a long wire. They have told all of that in this particular question. Now, there is one interesting thing happening. If this theta is small, oh, before that, okay. Isn't this force perpendicular always? Isn't this force always perpendicular to the velocity? I just told you, I mean, come on, it's a cross product. QV cross B, force is always perpendicular. So, will the speed change? Will this value of V change? The answer is no, right? The velocity might change the direction, but magnitude will always remain V. That's understood. It cannot change the speed, obviously. Now, here is the next thing. Think about the velocities components. Okay, think about the velocities components. Okay, there will be two components, obviously. Just get rid of this. Yeah, one component here, which is Vx, and one component over here, which is Vy. Now, if I want to find theta, I know what to do. It's very obvious now. Draw a small triangle. This over here is V, this is Vy, this is Vx, this is theta. So what you need, actually speaking, is tan theta, which is Vy by Vx. But since theta is small, look at this, small deflection, tan theta is roughly theta. So understand, you can just find theta by finding tan theta, which is Vy by Vx. Everybody clear? Great. Now the next step is, what is Vx and what is Vy? How do we figure that out? That is also simple. How is that also simple? Listen to this, guys. Because this angle is small, think what will the x component be? This x component will approximately be V only. This is V only because this angle is small. Think about it. This is x component, this is y component, this is y, this is x, this is theta, this is V. So what about the x component? Don't you see? Because theta is small, the x component is actually equal to V. And if you do not believe it, think of it this way. V cos small angle like 0. V cos 0 is 1. So it will be V approximately. This angle is very, very small, tending towards 0. Is this point clear till here? Very good. Yalini says understood. Hello Vasanthi, welcome aboard. Hello Dinesh. Hello Remo, welcome. Yep, great. Now what to do next? I know the value of Vx. Okay, I know the value of Vx is V, approximately rather. It is approximately V. Cool. The only problem is finding Vy, right? Only problem is finding Vy, correct? Now think, how do we find Vy? Oh, and you can make another approximation. Is this force approximately in the vertical direction? Because hardly the path has changed. There is small angle of deflection. Can I say the force is approximately vertical? Approximately vertical. Think about it. If that force is approximately in the vertical direction and it will be also constant approximately, think about it. The force hardly has changed. So the vertical component is almost F only. That means I can say this force for that small duration has caused an impulse. Force into time will cause impulse in the vertical direction, which has caused this y velocity. So the force in the y direction has created an impulse in the y direction to change the momentum, and that's why there is a y velocity. Acha, that means that change in the momentum in y is that force into the time for which it acts. So the change in momentum in y is the force in the y direction into the time for which it acts. Remember, it goes very quickly. This word quickly gave me the hint that probably there is impulse in the question. If this word quickly was not there, then probably I would not think about it. This word should give me that hint. So that's what I say. Whenever you read the question, read between the lines. Try to think what does each word mean. So quick force. It goes quickly, tuck, there is a force. It changes the y velocity, and that's why there is a sudden change in the direction. So that impulse has caused that y momentum. Great. So what is that force? Well, that's QVB. Q into V into B. But what is B? B is this value. B is this value. So that is mu naught I by 2 pi distance. What is my distance? It's roughly R. I hope you see that throughout the wire, the distance is roughly R. There is hardly any change in the distance. So this is the distance. So the distance is basically R. So I'm just going to put R over here into the time. Okay. So this was basically the magnetic field and into the time. Now the only thing left is Q V mu naught I by 2 pi R. Change in momentum is mvy minus 0. So this is just m into vy. Change in momentum is final minus initial momentum. What is the value of time? How much time does it take to go from here to here? Think about it. Time is distance by speed. I don't need this anymore. This time is distance by speed. What is the speed, guys? It was constant, right? It was just v. So it is nothing but L divided by v. Just use this over here. So therefore mvy will be equal to q v mu naught capital I, okay, divided by 2 pi r into the value of time. Oh, the value of time is L by V naught. L by, oh sorry, not V naught, just V. L by V. Oh, this V and this V will cancel. This V and this V will cancel. So finally V will not be there in the answer. Finally V will not be there in the answer. So I will just have Q mu naught I L and divided by 2 pi r. I will just have this divided by 2 pi r, nothing else. So last step is theta. Theta is Vy by Vx. Okay, you can even take this m below. If you can even take this m below if you don't like it. So this will become 2 pi rm. Okay, so I've just taken this m below. So theta is Vy by Vx. What is Vy? This entire thing. Q mu naught I L divided by 2 pi rm divided by Vx. What is Vx? Vx is just V. That's it. So that is my final answer. Sai Saran, electrostatics is already done, bacha. You can check out the playlist. It's already done. Check out the playlist. Good morning, Harish. Welcome aboard. Yep. So, lot of things out here. Beautiful question. So, kinematics was not needed because quickly word was used. So, I used the concept of impulse. What an amazing question. How many of you loved this question? This is proper advanced question, guys. Very good, Yalini. Okay, so what has happened? This wire, which produced magnetic field, deflected it by small amount. Because the deflection was very small, the horizontal velocity was same. Only the y velocity has been gained because of the force produced by the magnetic field. This force was sudden because it acted for a small time, and that force caused, force into time is change in momentum. So just substitute force is QVB. What is the value of magnetic field? Just put it. It's pure maths. You will get the y velocity. And lastly, use geometry. Theta is tan theta, which is Vy by Vx. Vx is V. Vy, we just figured it out from here. That's it. Yes, Aju, definitely. Obviously, if you are 2021, you should watch it, in fact. Yeah, obviously, you are going to give advance in some months. Obviously, you need to be prepared. So that's the answer, guys. Yeah, we just got it. How about this question? Hanum, no. It's just a question. That's it. But these are the kind of questions which are generally asked. Okay, let's see how many of you can do this. This is relatively simple. So the previous one was quite lengthy. This is not very lengthy. This is very easy. Let's see how to do this. There is magnetic field acting in the upward direction. There is a rod which is sliding down, and this is an inclined plane. The question is, if the speed is constant, what is the amount of magnetic field in the vertical direction? We don't need options anyways. Let's just try to think about, what are the different kinds of forces acting on it. So before that, let's look at the side view. So the rod was sliding down like this. So if I look at it from the side, I'll just probably see, this inclined plane, this rod is here and it is sliding down like this. Magnetic field is vertically up and the speed is down the inclined plane. Everybody fine till this point? Rashi, probably leave a comment, bacha, or ping me on my Instagram handle, which is Shreyas_Vedantu. Definitely, I will tell you how to exactly cover up backlog, because it depends from person to person. Thalapati Giri, I hope you can still avoid the class and somehow attend this class. Okay. Sai Saran, I explained just some time back. Where is electrostatics? Okay. Cool. Let's see how to solve this. First of all, this word is very important. Constant speed. If speed is constant, tell me what would be the acceleration? Come on, answer in the chat box, everyone. What is the acceleration if speed is constant? This is very easy. Hello Prajwal, welcome aboard. Hello Sai Sashank, come on my warriors. If it comes down with a constant speed, why it comes down with a constant speed, we'll figure that out later on. Yes, correct, the acceleration is 0. So what will be the net force acting on it? Obviously force will also be 0, net force. Now whatever forces are acting should cancel out each other. Okay, so what are the forces acting on it? And that one is very obvious, like there will be a normal force like this. Okay, mg will be down, but mg will have two components. One will be mg sine theta and the other one will be here, and that would be mg cos theta. Don't you see, normal mg cos will balance. That's not our concern. The concern is in the inclined plane direction. There should be somebody to counter this mg sine. Only then it will not have any acceleration. So there will be some force up the inclined plane, and obviously this magnetic field is responsible for that. Now think about it, that the wire is like this, in and out of the plane. It's sliding down this way. It's sliding down like this. So I hope you remember that whenever a wire carries some current, okay, it will have, yes, it will have some magnetic force because of the current which is carried in it. And the force is IL cross B. Length is here, magnetic field is up, length is towards you, magnetic field is up. So think about it, length cross B is this way. Obviously do not do length cross B, okay? like that, it won't make sense. So to length cross B, look at it. Where is the force coming? It's coming towards your right side. Just check this out. Length is inside, magnetic field is up, so the thumb is pointing towards the right side. So that means the IL cross B force is over here. ILB force is here. That's the catch. Now, the logic is, I don't need this force. I need the components of this. So I don't need this force. So think what component will act in this direction. I don't need ILB. Just think about it. If this is ILB, this is theta. What's the component in this direction? Obviously, it will be ILB cos theta. I don't care about that sine theta component anyways. That ILB sine theta will be here. Because it's in this direction anyways, normal force will take care of it. I should be more concerned about this direction because mg sine should somehow be nullified, should be cancelled. Hence, for net force to be 0 along the inclined plane, okay, along the inclined plane like this, there should be cancellation of forces. That means mg sine theta should be equal to ILB cos theta. Now what was the question? The question is magnetic field. Okay, so B will be equal to, M is there, G is there, cos goes below, so it will be tan theta, and you will have I below and also L below, and that should be the answer. mg by IL into tan of theta. That's it. Done, done, done. Newton's laws, and that's it. Just resolve the forces and magnetic fields forces on a current carrying wire. As simple as that. Beautiful question, guys. You can see that. That's the answer. Archana, like I said, as soon as 2021 batch examinations are over, we'll start with Pathfinder series continued, and we will take bigger sessions to make sure that your portions get over. So meanwhile, those of you who have missed, let me just show this to you. If you are on this channel, probably you can see the playlist, guys. You just click playlist. Okay, just click playlist over here. You can see, you can go below. Okay, you can see physics. You can click on physics, and you will see electrostatics 6 lectures, Gauss law 5 lectures, current electricity 7 lectures, capacitors 5 lectures, Ampere's law, solenoid, and all these things. Today is the 5th class of this. All these playlists are there. You can watch anything. Let's say you want to watch electrostatics right from the beginning. Okay, start, and there you go. You can see all the playlists are over here. Okay, so do that. That's what you need to do in case you have backlogs in these next 1-2 weeks. Trust me, we are completing the portion. I'm going to make sure your portion gets completed in a proper way. There is no point hurrying it up. A lot of people think, sir, now examination will happen, sir. You should complete everything in 1 month. If you complete everything in 1 month, then I'm guaranteeing you, you will fail the JEE Mains examination, because you know you need to do it systematically. We have time. Don't think that we don't have time. We have time, and just follow whatever lectures I'm taking up here in a proper sense, in a proper way, in a proper systematic way. Make your schedules, make your timetables aligned with our classes. Trust me, it will work out. Okay, so let's get going to the next question. This is very easy. Oh my god, why did Yalini block Priyanka? I don't know why. What happened? Oh my god. Okay, Ajo Saran, cool. How do I join the topper batch? You need to just perform well in your tests, Chinmaya. Okay, that's all. Automatically you will be noticed. Nothing great about it. You just need to perform well. Just focus on learning. Don't focus on sir, topper batch, this batch. Everything will happen. Just keep doing well. Okay. So there is a wire which carries current, and there is a path, semicircular path of radius r. The question is, what is the integral, line integral of B and dl for this semicircular path? Now the first thing that you should think about, what is the meaning of this word line integral? Line integral means integral B vector dot dl. That's the meaning of line integral. That's it. Length is there, so that's why line integral. Okay. From C to D along the semicircular path. Now, I feel this is a question based on Ampere's law. Now, if you remember Ampere's law, you will recollect cyclic integral B dot dl is mu naught into I enclosed. Mu naught into I enclosed. That's the value of the B dot el cyclic integral. Cyclic means the closed path. Do I have a closed path? Well, I don't think I have a closed path. So let's close the path. How? By showing more dotted lines like this, and I want to go from C to D, right? So I go like this, like this, like this, and I continue going along that same path this way. Okay, so this is a closed path. Cool. Enclosed current. What do you think is the value of this enclosed current inside this path? Remember, there is a wire which is carrying current this way, here outside that loop. So what is the value of enclosed current? Think about it. Come on, my warriors, think about it. What is the value of enclosed current? So JST, magnetic field can arise because of moving charges or current carrying wires or bar magnets. So always keep this in mind. So whenever moving charges are there, basically in a current carrying wire, charges move. So that will produce magnetic field, or you have a you have a bar magnet. So bar magnet or horseshoe magnet, that also produces magnetic field. But again, in a horseshoe magnet, bar magnet, etc., at the end of the day, there are those atoms which are spinning, the charges are spinning, and those charges which spin and rotate and revolve, they produce tiny loops of currents. Those currents produce magnetic field. So at the end of the day, currents produce magnetic field. Just keep this in mind. What is moving in circular path? Nothing is moving. You have to go. Ajo Saran, I hope you have heard about Ampere's law. In Ampere's law, you always choose a path. What moves along the path? Nothing moves. You are hypothetically, okay, maths wise you are moving. You are going from this point to this point to this point to this point to this point. You are moving along that path, and at every point you calculate the dot product of B and DL and you evaluate that integral. That's the meaning of evaluation of that line integral. Okay, everything, be it ring magnet, everything, it's all the same thing. End of the day, it's a permanent magnet. So guys, what's the enclosed current? You guys didn't answer it. What is the current inside this loop? Is there any current piercing that loop? Is there? Come on, think about it. There is no current, right? So the answer for this will be 0. Okay, so the enclosed current is 0. Now, this is a cyclic integral. Cyclic integral means you start from here and go till here and come back over here. So go from here till here and come back over here. So I think I can split that cyclic integral into two parts. One is that semicircle. And I do B dot dl, okay, plus the remaining path I go along the diameter, cyclic integral B dot dl. So along that diameter. Now the best part is this wire, okay, which carries current, it will produce magnetic field like this. You can use your right hand. You can see the magnetic field will be like this. Okay, so because of that, think about it. If the magnetic field is here and if the dl vector, I'm going along this path, I'm going dl, if they both are perpendicular, what is the dot product of both of them? B dot dl, magnetic field is like this, dl is here. Help me with this answer. Think about it. Yes, no current, Yalini. Yes, no current, Priyanka. Very good, 0. What is the dot product of B dot dl? Two vectors perpendicular. Yes, it's 0. So this should be 0. And hence, I will just have B dot dl of the semicircle. And remember, this is also 0. This is also 0. So hence, the answer to this question is 0. So the integral from here to here, you don't have to sit and actually integrate. That's the best part. It comes out to be 0 by just using Ampere's loop law, nothing else. So the answer is 0 for this question. Amazing question. So there was an incomplete loop. You completed the loop. You just saw the total enclosed current is 0. Great. So the RHS of the Ampere's loop law is also 0. Now next thing you saw, the magnetic field lines which are produced by the wire are perpendicular to the length or the path along which you are traveling. So that dot product is 0. So the dot product is 0, this integral is 0. So only this integral remains, the answer is 0. Yep. So it's very simple, it's not that difficult, Ajo. So it's just that probably you're not used to solving advanced questions. So if you're used to solving advanced questions, if you are practicing at home, trust me, this is not very difficult. It's probably, you just have to push yourself a little bit harder. So probably you need to solve more questions, that's it. Okay. Let's get going to the last question coming up on our screen. I hope you guys are full of josh. Thank you, Narendra. Definitely, Ajo, you should definitely watch live classes. You should not watch recorded classes. I mean, the fun of watching a live class is completely different. Badari, just solve lots of questions. There is nothing like tips for electrostatics, tips for magnetism. Solve everything, and you need to have really strong visualization for this chapter. So there is a loop which carries current, and it's hanging from 2 wires, and there is magnetic field in the horizontally left direction. The question is, find the tension in this string and that string. That's the question. Find the tension in the strings. Okay. One thing is obvious, the tensions won't be same. Okay. So if I look at probably the side view of this, okay, just hold on. I'll probably look at the side view. Okay. So this is the wire. This is my loop. Okay. So what I'm going to see is there is going to be tension 1 from here, there is going to be tension 2 from this wire, there is going to be mg below, and just because of this magnetic field and this current, you are going to experience a torque on the loop. Do not forget, torque is m cross b. M, magnetic moment of this loop. Try to figure this out. Use your right hand, curl your fingers in the direction of current, your thumb goes up. So the magnetic moment is upwards. You can see that magnetic moment is upwards. B is towards the left. Magnetic moment is up. B is towards the left. Do M cross B. M cross B. See where is the torque? It's coming like this. It's anti-clockwise. So this torque is obviously anti-clockwise. Is this point clear? So the torque is like this. The torque is in this direction. So this is the direction of that torque. I'm just putting it over here. Okay. Now, what's the value of this torque? That's not that difficult. So the value of this torque, which is MB, actually sine 90 degrees. Reason of 90, M is this way, magnetic field is this way, both are perpendicular to each other. M is NIA, N is only 1, I is current I, into A, which is just probably given somewhere, it's pi r square, I think. Yeah, the radius is r. So it is pi r square, and B is just B naught, nothing else. So this is nothing but I pi r square B naught. So that's the torque produced by that magnetic field. Now since this system is at equilibrium, it's very obvious because it is not rotating, the net torque should be 0. The net torque produced by all the forces should be 0. So how about measuring the torque at the center? So measure the torque at the center. So all the torques should cancel out each other. So torque by tension 1 plus torque by tension 2 plus torque by mg, okay, plus torque by the magnetic field, all of them should add out to be 0. What is the torque? Okay, what is the torque produced by T1? Okay, so this was T1, this is T2. Okay, so understand T1 will have two components, one component here and the other component here, and this angle is theta. Same thing, T2 will also have two components, okay, and this angle is theta, which is 60 degrees or something. Yes, theta is 60 degrees, it's given. What about the magnetic field due to the coil, Anushk? The magnetic field due to the coil will produce probably field in the upward direction, but that cannot apply a torque on itself. Remember, when I say torque is mb sine theta, it is a field due to some other thing, some other external source. Same field cannot apply a force on itself. So this was external. The coil producing magnetic field will not cause a torque on itself. So please get that clear. Okay. Equilibrium should be given. Well, even if it is not given, it is suspended, right? It's just suspended. So that means it is stationary. So you don't have to worry about it. So it's just stationary. Okay. Now don't be sorry, Anush. It's fine. You can ask your doubts. No problems. So what is the torque by T1? Look at this. This distance is R, and the torque will be produced by only the cos component, not the sine component. Because the sine component passes through the point. Remember, torque is only produced if you have a force which passes through the point, no torque. If you have a force which is away from that point, yes, it produces a torque. So the sine component will not produce torque, only the cos component will, and the torque will be R into T1, what is it? Cos theta. Same thing, torque by tension 2 will be in the opposite direction. If this tension produces torque this way, this tension will produce torque the other way. You can see this torque is this way, this torque is other way. Mg will not even produce torque. Okay, it will not produce torque. Magnetic field is producing torque this way. So instead of plus, I need a minus sign, and it will be R T2 cos theta. R into T2's cos theta. That's it. Okay, last step. Okay, this is 0, and torque by magnetic field again negative, because I'm taking this direction as negative, that direction as positive. This is the value of the torque. So I pi R square B naught is equal to 0. This is what I get. Okay, cool. So let's just simplify this. Therefore, R gets cancelled. T1 cos theta, cos 60 is half. So T1 by 2 minus T2 by 2. All right. Minus I pi R B naught is equal to 0. That's what I get. Shift this guy on the other side. So you will get T1 minus T2 is equal to 2 I pi R B naught. This is equation 1. There are two unknowns and only one equation. Won't tension produce torque in the same way? No, Anush, how can it produce torque in the same way? This tension about this point will pull that body clockwise. This tension will produce a torque anti-clockwise. So both the tensions will, be opposite. Yeah, in torque wise. Hanum, yes, you will be having other class, but that's for 2021 batch, and that's complete mechanics revision. Yep. Now there is one more equation I need. And what is that equation? T1 plus T2 cos component. T1 plus T2 cos theta component will be balanced by mg. Look at that. T1's cos theta, T2's cos theta will be balanced by mg. This is just a torque. There is no force by magnetic field. Net force is 0. So don't worry about this torque. It's like a couple force. So T1 cos, T2 cos will be balanced by mg. So therefore T1 plus T2 cos theta is half is equal to mg. Therefore T1 plus T2 is equal to 2 mg. This is my equation number 2. Okay, now I think things are very obvious and simple. All you need to do, I don't need this anymore. Okay, I don't need this anymore. Just solve these two equations. Just add 1 and 2. Just add 1 and 2. See what do you get. Just add both of them. T1 plus T1. T2 will get cancelled. So you'll get 2T1 is equal to this thing. So you'll get 2 mg plus 2 I pi R B naught. So therefore T1 will be equal to mg plus I pi R B naught. So this is the first value you got. Now take this value and put it either here or there, doesn't matter. So if you put it here, what are you going to get? Mg plus this whole thing I pi R B naught plus T2 is equal to 2 mg. Therefore T2 is equal to, take these guys over there, 2 mg minus mg. This guy over there will become minus I pi R B naught. So that's the second value of tension. Yes, exam time, please ask. That's it. Cool. Okay, Hanu, very good. Don't worry, you will do really well, bacha. That's Captain Shreyas sir telling you. Okay, don't worry, you're going to perform really well. Just study well and keep attending the classes. That's all. Okay, beautiful question. Lot of mechanics, lot of rotation, torque, forces, balancing, equilibrium, and also the concept of M cross B out here, which is the torque on a current carrying loop. So guys, if you want to study under me and if you want to study under teachers like me, I'm pretty sure you would be now inspired. And if you were not aware that these kind of questions are there in JEE Advanced and all of that, so you better start preparing and better start taking up all the micro courses as well as the long-term batches, because we train you for the worst. And you need to know all kinds of questions, guys. How to solve mains questions, how to solve bedside questions, how to solve board questions, how to solve advanced level questions. So we give you KVPY training as well. It's all free. You don't have to pay a single penny once you're in our batches. And you also get test series, assignments after every class. And you are going to have an option to learn in Hindi as well as English, which is a very good plus point. Remember, the prices are very low. Look at this price, 3,000 per month for all the packages like you can choose, and you get what? Live classes, recordings of that, test series, analysis, notes, PDFs, the Tattva module, hard as well as soft copy, doubt solving during the class. Now, if you want somebody to solve your doubt after the class, then go for the classic version. And if you want somebody to actually mentor you, then go for the plus version. I would say at least try out light or classic for 1 month, or if you want some mentor, then go for the plus version. The batches, are starting, guys, not on 28th June, they have already started, and some of them are starting this week, this Monday. You will be seeing a lot of new batches out there. So in fact, you can go ahead, just open up this link out here, which is there in the description box. Where is the description box? Here, and there you go on the link, the JEE Mains test series, JEE Mains crash course. Okay, yeah, there you go, the pro course. Just click on it, and there you will see the entire long-term course, other courses, revision, topic specific short courses, all the plans detailed out. So when you use the coupon code, you can see you can save 10% out there. Just try it out for 1 month. You will see all the details are mentioned. The syllabus, the timetable, whatever will be a part of this course. Every detail, whatever you need is mentioned out here. So just check this out. This link is very important. Okay, so just do that. Thank you guys for being here. Glad you guys have enjoyed it. Thank you, Priyanka. Thank you, Yalini. Thank you, Rashi. Very good, Chandrasekhar. Very good, Ajo. All right. Yep. Anush says surprisingly easier than you thought. No problems. How many marks is good for IIT? Well, don't think about it that way. Think about it this way, that you have to get a very good rank below maybe around 2,000 or 3,000 to get inside IIT. So for that, you need maybe around say 70 to 60% of the marks which are there in the examination. You don't need 100% or 90% also. Even 60 to 70% is going to give you a very good rank in IIT. That's how it works. Okay, cool. So thank you guys very much for being here. Take care, bye-bye, and do not forget to hit the subscribe button in case you haven't, and also hit the like button to show your love and support. Hasta la vista, this was Shreyas here.